Hi, welcome to iPrint. This video is a quick review of our course on maintenance planning and production planning in aircraft maintenance. Use this preview as a reference, and if it resonates with you, you can directly enroll for the course by visiting the link given in the description box. For customized discounts and for corporate training inquiry, you can reach us via the email and the contact number that is mentioned on the screen. Enjoy your preview.
Welcome everyone. Let's start our training with one of the most important topics, aircraft lifecycle management. The aviation industry is highly regulated, and so is aircraft maintenance engineering. In this training module, we are going to discuss about EASA framework. Do you know the aviation industry is highly regulated? Here comes the EASA. Oh, this is the reason that aviation travel is very safe. You might wonder how each aviation regulator ensures that aviation standards in their respective country as per the same standard. So here is the answer. It is possible because of the International Civil Aviation Organization, ICAO, which is an agency of the United Nations, UN. The International Civil Aviation Organization takes care of the administration and governance of the convention. You may wonder, how does the process start? As we know, the whole aviation process strictly follows aviation regulations and requirements. Mainly, the whole process is divided into three parts. It starts with the initial airworthiness of the aircraft. Afterward, it follows the continuing airworthiness of the aircraft. Finally, it goes through end-of-life process. Now, let us understand about initial airworthiness. As an aircraft is designed and manufactured, a type certificate is issued by the Aviation Regulatory Authority of the country of aircraft manufacturer. Each aircraft, before coming into service, is issued with an international registration marking known as a certificate of registration. Each registered aircraft needs a certificate of airworthiness, which shows that the aircraft is worthy to fly in the air. So, before any of the aircraft makes any revenue flight, it must obtain a certificate of airworthiness. The whole process until this stage is known as initial airworthiness. To continuously maintain aircraft airworthiness, continuing airworthiness plays a vital role. Let us understand the regulations that control initial airworthiness. So, as per EASA regulations, it is Part 21, which takes care of three key areas. First, Type Certificate of Aircraft. Second, Certificate of Airworthiness. Third, Noise Certificate of Aircraft. Soon after an aircraft receives initial airworthiness, it is mandatory to ensure continuity of airworthiness. The whole process of continuing airworthiness is cyclic and revolves around two vital processes. It starts with the identification of continuing airworthiness requirements. It falls under the purview of Part M regulation. Secondly, plan continuing airworthiness requirements. It falls under the purview of Part M regulation. Thirdly, execute continuing airworthiness requirements. It falls under the purview of Part 145 regulation. Finally, record execution of continuing airworthiness requirements. It falls under the purview of Part 145 regulation. Qualified manpower required to perform continuing airworthiness requirements falls under the purview of Part 66 regulations. which stipulate licensing requirements for the personnel involved in the execution of continuing airworthiness requirements. Considering specialized training requirements, another vital regulation is Part 147, which is mainly maintenance training organizational setup. This is the organization or training school where aircraft maintenance engineers get trained. Let us understand regulations that control continuing airworthiness. So, as per EASA regulations, mainly 4 regulations play a crucial role in it. Part M, Continuing Airworthiness Management. Part 145, Maintenance of Aircraft and Parts. Part 66, Licensing of Personnel. Part 147, Maintenance Training Organization. Part M, mainly known as Continuing Airworthiness Management Organization, CAMO, which identifies aircraft maintenance requirements to ensure its airworthiness is managed. Part 145, mainly known as Aircraft Management Organization, AMO, which physically executes aircraft maintenance requirements as per regulatory standards and produces maintenance execution records, physical or digital. Part 66, Define licensing requirements for aircraft maintenance staff. Part 147, Specialized Training Organization to train aircraft maintenance engineers. After using an aircraft for a predefined duration or lifespan, it passes through the end-of-life process, which is part of a circular economy. This also known as aircraft harvesting. Aircraft harvesting is a systematic recovery of usable parts and components from retired, damaged, or decommissioned aircraft, which is the process of end-of-life management and involves dismantling the plane to extract valuable parts for reuse, resale, or recycling. You might have a question about why aircraft harvesting is required. In addition to its being part of the circular economy, there are 6 prime factors before aircraft enter the harvesting process. First, age and usage. After a predefined age, aircraft should be retired from service. Second, maintenance cost. As the aircraft grows old, it is more prone to corrosion and fatigue cracks. Third, safety and sustainability. Aircraft are safe and sustainable up to a finite period. Fourth, technological advancements. Due to continuous technological evolution, upgrades are required for better performance, fuel savings, and other factors. Fifth, regulatory compliance. Certificate of Airworthiness and annual review do not find aircraft fit for operation. Lastly, economic factors. Aircraft operations do not seem cost-effective, and it is better to retire. Let's understand the steps involved in aircraft harvesting. Aircraft harvesting is a 7-step process. It starts with aircraft decommissioning from active fleet. Then it goes through an evaluation and planning process to list aircraft parts that can be removed from decommissioned aircraft. The third step is the removal of aircraft parts which are identified in the second step. The fourth step is the inspection and testing of removed parts. In some instances, aircraft parts are being used without testing as well. The fifth stage is the refurbishment and testing of aircraft parts as per the requirements. The sixth step is the storage and sale of recovered parts for further usage by aircraft operators. The last step is recycling and disposal. What is decommissioning? The aircraft is officially removed from service and transported to a dismantling facility. Necessary certifications and documentation are reviewed to ensure compliance with aviation regulations. What is evaluation and planning? A detailed assessment is conducted to identify parts that can be salvaged based on their condition, demand in the market, and airworthiness. A harvesting plan is prepared to determine the sequence of dismantling. What is component removal? Component removal involves critical and high-value components such as engines, avionics systems, landing gear, and control surfaces are removed first. Specialized tools and equipment are used to ensure precision and prevent damage. Parts are tagged and documented to maintain traceability. What is inspection and testing? Inspection and testing involve removed components being inspected and tested for functionality. Certification processes may include detailed non-destructive testing, NDT, to ensure compliance with aviation standards. What is refurbishment and certification? Refurbishment and certification involve parts that meet airworthiness criteria are repaired or overhauled as needed. Certified aviation authorities or licensed facilities issue airworthiness certificates for the refurbished components. What is storage and resale? Storage and resale involve salvaged parts that are cleaned, packed and stored in warehouses. These parts are sold to airlines, MROs, or other operators. What is recycling and disposal? Recycling and disposal involve components that cannot be reused and are recycled for materials like aluminum, titanium, and composites. Hazardous materials are disposed of according to environmental regulations. Now let me explain about aircraft parts that are removed for further use on aircraft or sale. These are also further divided into two categories. The first category is aircraft parts with approved documents. If the part has been recertified as overhauled or bench-checked by an authorized facility, a warranty is often provided. The second category is aircraft parts sold as removed or as ES. If the part is sold as is or as S without inspection, testing or certification, no warranty is typically offered. In such a scenario, buyers are expected to assume the risk and may conduct their inspections. Since you are now familiar with the entire process, from aircraft production to its final disposition, now it is time to explore the key management aspects involved in this whole process. These can be broadly divided into four main areas from a business perspective. First is design and production management, overseeing the aircraft's development and manufacturing process. Second is operations and revenue management, managing the aircraft's usage in flight operations and optimizing revenue generation. Third, airworthiness management, ensuring the aircraft's continuing safety and regulatory compliance throughout its operational life. Fourth or last one is disposition management, safely handling the aircraft's retirement and end-of-life processes. Together, these areas constitute aircraft life cycle management. Thank you for your attention. That brings us to the end of this topic. I hope you have a better understanding of it, and we will now look at some additional information.